Hello, thank you for coming to see my video. My name is Sang-Yun. My presentation is on camera-based synthesis of motion effects, emphasizing on moving objects in 4D films. 4D film is an immersive entertainment providing various physical effects with audiovisual content, and they are gaining more popularity and acceptance. One of the most frequent 4D effects is the object-based motion effects, which emphasizes an object of interest by chair motion. In this work, we present an algorithm for automatically synthesizing convincing object-based motion effects. An object can freely translate and rotate in the 3D camera coordinate system, leading to a 6D OF motion. In contrast, most commercial motion platforms in 4D theater have only 3 DOF. While watching many 4D films, we observed that both object translation and rotation are expressed as motion effects. Also, we noticed that the motion amplitudes for the translation and rotation depend on the object size. Based on these observations, we set our research goal as designing an algorithm creating the motion effects that simultaneously express the translation and rotation of an object in the motion platform's limited workspace and DOF while seamlessly modulating the motion effects amplitude based on the object size. To transform the full 6D OF object motion to 3D OF motion effect, we introduce a new concept, motion proxy. The center position of an object only reflects the translation, and the direction of the object only reflects the rotation. The point that is shifted from the center position in the frontal direction reflects both translation and rotation. We refer to this point as the motion proxy for the object, and our algorithm centers around the motion proxy while considering the visual size of the object. Our algorithm takes position, direction, and size of a moving object of interest and then generates a motion commands through 3 steps: computing motion proxy, estimating visual velocity, and motion queuing algorithm. To determine the position of the motion proxy, we performed the perceptual experiment. The result showed that the motion proxy shifts from its position in proportion to the object size, which implies the role of rotation becomes more important as the object size increases. Now let's move on to the second step, the estimating the visual velocity. This step aims to generate the motion effects matching the visually perceived motion of the motion proxy. To this end, we formulated the visual motion vector by referring to Dunker's two modes of object motion perception and motion field equations. And then we designed our algorithm to support the two modes, subject relative mode and object relative mode. The third step is motion queuing algorithm. This step uses the visual motion of the motion proxy to produce motion commands. To represent the motion in the limited workspace of the motion chair, we adopted two approaches, washout filter and model predictive control. We designed 3 algorithms using each approach while considering visual and vestibular perception. We adopted MV to our algorithm, which showed the best perceptual quality in our experiment. Finally, to evaluate the performance of our algorithm, we conducted a user experiment. Participants experienced 5 sets of motion effects with object moving videos. 2 were for the perception modes of our algorithm, 2 were for the state-of-the-art Lee et al. Algorithm, and the other one was a randomly generated effect. Then participants rated 7 subjective metrics: harmony, synchronicity, comfort, distraction, enjoyment, and preference. Consequently, we got these results. The two modes of our algorithm showed better performance than the others for the most metrics. In conclusion, we have summarized the contribution of our research as follows. First, we proposed a novel concept which enables expressions of a 6D OF object motion with a 3D OF motion chair. Second, we formulated the visual velocity to create motion effects synchronized with what humans visually perceive. Third, our algorithm produces compelling 4D experiences by considering human perception while fully utilizing a motion platform's workspace and DOF. This is the end of my talk. Thank you for watching it.